Okay, today I'm going to discuss Clebsch Gordon coefficient for j is equal to 1. Sorry, j1 is equal to 1 and j2 is equal to 1 divided by 2. For that, first we need to find m1 and m2 values. So let us take first j1 equal to 1, right? Is given. So then once we know the j1, we can find easily m1 value. m1 is equal to 2j1 plus 1. This is the formula. Then substitute j1 here. m1 equal to 2 into 1 plus 1. So m1 has 3 values. m1 equal to possible values 1, 0, minus 1. These are the 3 values. Next, j2 is equal to 1 divided by 2 is there. Similarly, we can find m2 value 2j2 plus 1. Substitute this j2 value here. m2 is equal to 2 1 divided by 2 plus 1. Then m2 has 2 values. So 1 by 2 is there. 2 possible values are one is plus 1 by 2, another one is minus 1 divided by 2. So we have j1 equal to 1 and m2 sorry m1 m1 equal to 1 comma 0 comma minus 1. And next one is j2 equal to 1 divided by 2. Value m2 I got 1 divided by 2 comma minus 1 divided by 2. So next step is to find j and m values. So pi j m and wave function psi equal to m1 and m2. So by adding linear combination of this wave function and we can get this one, right? So which is why I'm finding m1 m2 values, j1 j2 values at j. For that, if in case if I find m1 m2 value, then I can get j1 j2, then I can add j1 plus j2, I can get j value. Okay, so here I'm going to find j and m values. So we know the formula of j equal to, once we know j1 plus j2, modulus of j1 and j2, right? So first we need to find what is the maximum values. For that, j is equal to, you need to take j1 plus j2, 1 plus 1 divided by 2. So that is equal to 3 divided by 2. We get maximum values, that is 3 divided by 2. Important. Then m equal to, what is the m value here? 2j plus 1. So j is equal to 3 by 2, right? So therefore 2 into 3 divided by 2 plus 1, that equal to 4 values are there. So m has the 4 values. So m is equal to 3 divided by 2. In between 3 divided by 2, so m has 4 values. M equal to 3 divided by 2 and minus 3 divided by 2. In between 3 divided by 2, 1 divided by 2 is there, and minus 1 divided by 2 is there, minus 3 divided by 2. Okay, fine. Next, second point here is, if we take j is equal to j1 minus j2, then you can get the minimum values of c. 1 minus 1 divided by 2, because j1 is equal to 1 and j2 is equal to 1 divided by 2 is equal to 1 by 2. These are the minimum values. Minimum values. So in case minimum value is there, what is m? M equal to 2j plus 1. So 2 into 1 divided by 2 plus 1, 2 values. So here m has 2 values. M equal to 1 divided by 2 comma minus 1 divided by 2. And the final step is to find out how many rows are there, how many columns are there. So for that we need to find number of rows and columns by using the formula. I'm using 2j1 plus 1 into, okay, 2j2 plus 1. So j1 j2 value I know. Substituting j1 j2 value, plus 1, 2 into this one, 1 divided by 2 plus 1, 3 into 2, so 6. So 6 columns and 6 rows. Therefore 6 columns are there and 6 rows. So let us try to draw the table here. Mm. Okay. Oh. So here I'm taking m1 and m2. Here I'm taking j and m values. So we know, right, what is m2 values? How many m2 values are there? M2 values. There is m2. So m2 is equal to 1 divided by 2 minus 1 divided by 2, right? Is equal to 1 divided by 2 minus 1 divided by 2. So first you need to understand what is m1 and what is m2. How we can get m1 and m2, and how get j and m values. So here m2 values, how many rows are there? 6 columns are there, 6 rows are there. So here m1 and m2 values, only I got 1 divided by 2 minus 1. Okay. So here I am going to write this m2 values like this: 1 divided by 2 minus 1 divided by 2. 1 divided by 2 minus 1 divided 1 divided by 2 minus 1 divided. So m1 value, m1 value is 1 0 minus 1 is there. We want to write these 3 values into the 6 values. So here is 1, here is 1 and 0, 0. This is 1, this is minus 1. So if you add m1 and m2, you can get m value. If you add m1 and m2, you can get m value. If you add m1 and m2 value, you can get the final m values. So like that, here the j value is also there. What is j value here? And j minimum and maximum value. What are the j minimum and j maximum is 3 by 2, 1 divided by 2, minus 1 divided by 2, 3 by 2, right? And minimum value is 1 divided by 2, 1 divided by 2. These are the 4, the 6. So here I'm going to write these 6 things here, m values, whatever I got above. One is 3 divided by 2, another one is 1 divided by 2, another one is minus 1 divided by 2, another one is 3 divided by 2. So j is minimum value. If j equal to 3 by 2, if j is equal to 3 by 2, then I got these things. Remember, if j is equal to 1 divided by 2, I got the minimum values. One is 1 divided by 2, another one is minus 1 divided by 2. Then you need to try to understand this matrix multiplication. So then you can get the values. So this is a1. Remaining things are 0, 0, 0, 0, 0, 0, and this is 0. This is a2. So this is a3. This final result, but I'm going to expand each and everything. So this is 0, this is 0, this is 0, and where is the fourth one? Minus 1. Only we got a4 and a5 got here, and remaining thing this 0. And this is 0, only 3 by 2, 0, 0, 0, 0, a6. Next, this one 0, this one is 7, this one is 8, this one is 0, 0, 8, 0, 0, 0, and then 0. This is a9, this is a10. These are the coefficient of j is equal to 1, J is equal to 1 by 2. We need to find what is A1 value. A1 value is equal to 1, A6 value is equal to 1. Remaining A2, A3, A4, A5, A7, A6, A9, A10. We want to find using J plus operator, J minus operator, normalization condition, orthonormal condition. So I'm going to write by using this matrix one equation like this. It's better to write it here itself. So please try to understand. Oh, okay. So what are the possible ways are there to get this thing? So we already know pi, this is j, this is m, and wave function psi, this is m1 and m2. Okay. If we add these things, then we can get m1 and m2 value. Only one possible thing is there, that is a1 wave function psi 1 comma 1 divided by. So in this case, a1 is equal to 0. This is equation number 1. Okay. Pi 3 divided by 2 comma 1 divided by 2. So this is the only linear combination we can get this. Psi is equal to 1 comma minus 1 divided by 2. Okay. Plus a3 wave function psi 0 comma 1 divided by 2. Right. Next, pi 3 divided by 2 comma minus 1 divided by 2 a4 wave function psi 0 minus 1 divided by 2 plus a5 wave function psi minus 1 divided by 2. 3 divided by 2 comma minus 3 divided by 2 equal to, this is a6 wave function psi 1 minus 1 divided by 2 plus, okay, it's enough. So a6 equal to 1. This is, I'm going to take equation number 2. So the only combinations are there, equation number 1 and equation number 2, that is a6 and a1 coefficient we already find. The coefficient of these things are 1. Minimum values 1 divided by 2 and 1 divided by 2 is there, not equal to the only linear combination. If you add this linear combination, then you can get this. Okay. This is 8 wave function 0 1 divided by wave function psi 1 divided by 2 comma minus 1 divided by 2 equal to a9 wave function size 0 minus 1 divided by 2 plus a10 wave function size minus 1 divided by 2. So we need to solve this coefficient by using our known condition. Okay, so please try to understand how I write these things. So we know these are the minimum values, right? Sorry, these are the maximum possible values. These are the minimum values. See here. So how many j values, maximum values? We got 4 values, right? These 4 values, I'm going to write these things like this. The minimum values are 2 is there, 1 divided by 2 minus 1 divided by 2. Only possible thing we can write here 1 divided by 2, 1 divided by 2, and 1 divided by 2 minus 1 divided. Okay, so these are the linear combination of the equation. Once we write this equation, this is the important thing to find out CG coefficient. You want to write equation correctly, then only you can find this CG coefficient value. So if we add J1, sorry, M1 and M2, you can get this J and M value. Then only will correct. Okay. So let us find this one, this is 2. Okay. Here I'm going to try to find these coefficients. So first I'm going to take apply J minus operator on this state. 3 divided by 2. Okay. So we know the formula of J minus, you apply J minus on this state, then we can get so J minus, right? The M state will decrease by 1. J M minus 1. The eigenvalues of J minus is root of J into J plus 1 minus M into M minus 1. So this is the formula where we get this formula. CG coefficient theorem is there, Clebsch coefficient or vector coupled theorem. Sometimes we can call this theorem vector coupled theorem. Okay, this is our state. I want to try to find out first A2 and A3 values. This is 2, not 1. A2 and A3 values. So this equation. For that, I need to take so pi 3 by 2 and 3 by 2 state. In case why I am taking here 3 by 2, 3 by 3 by 2 3 by 2 statements. If you apply j minus operator on this state, it will decrease one state, right? 1 divided by 2, then we can get 3 divided by 2, 1 divided by state. Then we can find j1, sorry, a1 and a3 coefficient values. Easy. So just try to apply this operator. So here I'm taking I 3 divided by 2, 3 divided by 2 state. So if you apply j minus operator, this is the operator on this state. So what we get? So first you can write this eigenfunction state 3 divided by 2. So j minus is there. So this is j, this is m, right? Only m state will decrease 1. So 3 divided by 2 minus 1. So root of so this is j into j plus 1 minus m into m plus 1. So what is j? This is j, this is m, right? Okay. 3 divided by 2 into 3 divided by 2 plus 1 minus 3 divided by 2, 3 divided by 2 minus 1. Here I got pi 3 divided by 2 comma 1 divided by 2. So by simplifying this equation, so we got root 3. Simplify this one, definitely got root 3. Then remaining thing pi 3 divided by 2 comma 1 divided by 2. So here I applied j minus operator on this state. I got this thing. Okay, we know one important information. We want to this state, right? I'm going to write this state here. Pi of 3 divided by 2 comma 1 divided by 2 equal to 1 divided by root 3. It is going here, right? J minus pi 3 divided by 2 comma 3 divided by 2. So why I am interchanging this thing? So I want this quantum state 3 divided by 2 state, 1 divided by 2 quantum state, right? So for that we can get a1 and a2 and a3 coefficient values. So we know already one important relation, wave function pi 3 divided by 2 comma 3 divided by 2 equal to psi 1 comma 1 divided by 2, right? See here equation number 1. So here a1 is equal to 1, right? So in place of pi 3 divided by 2, 3 divided by 2, we can use psi 1 comma 1 divided by 2 from equation number 1. Root 3, so j minus operator is already there. In place of this thing, going to replace wave function psi 1 comma 1 divided by 2. Okay. This is m1. You need to careful here. This is m1 and this is m2. What is this operator? This is j1 plus j2. We want to split this j minus operator into root 3 j1 minus plus j2 minus. Here minus is it. Okay. Lowering operator minus 1. Wave function psi. Because of m1 and m2 only, here I am splitting total j into j1 plus j2. You need to split this thing first. And 1 comma 1 divided by 2. Then you try to apply this j1 minus operator on this quantum state. You got the eigen values, I mean coefficient those values, a1, a3 value. So for that, root 3 is there. So j1 minus wave function psi 1 comma 1 divided by 2 plus j2 minus wave function psi 1 comma 1 divided by 2. Okay, so because of equation is, I'm going to write here root 3. Okay, so j minus, here I'm going to apply j minus, sorry, j1 minus, this is m1 and this is m2. Here m1 state will decrease by 1 state. j2 minus, here m2 state, this is m2 state. After applying this operator, m2 state decreases by 1 and we can get eigenvalues. So root after applying this j1 minus on this energy state, j1 plus minus m1 into m1 minus 1. So if minus 1, that is equal to 0. So I got here wave function psi 0 comma 1 divided by 2 plus root j2 minus eigenvalues j2 plus 1 minus m2 minus 1. So if we decrease m2 state by 1, so because of lowering operator minus, right, 1 divided by 2 minus 1 divided by 2. So you got minus 1 divided by 2, right? Okay. So here J1, what is J1 here? So from given problem, J1 is equal to 1, J2 is equal to 1 divided by 2. M1 here, the only this state, M1 is 1, here M2 is 1 divided by 2. You need to careful here. So apply all these M1 and M2 values. Root 3 root of 1 into 1 plus 1 minus, so m1 value here, why I am applying this m1 value, I am applying this operator on this wave state, right? Then you can get eigenvalues of these things, not other things. M1 1. So this is going to the, you try to write first, then you can write. Okay, right. One is 0, this one is 1 by 2 plus root of J2 value we know 1 divided by 2 according to the problem. 1 divided by 2 plus 1. What is M2 value? This is operator. This is state, right? So M2 is 1 divided by 2. Okay. Minus 1 divided by 2, 1 divided by 2, minus 1. Okay. A function psi 1 minus 1 divided by 2. So 1 divided by root 3. This is root 2. Wave function psi 0, 1 divided by 2 plus this is root 1. Okay. Wave function psi 1 minus 1 divided by 2. Pi 3 by 2, 1 divided by 2. Pi 3 divided by 2, 1 divided by 2. Starting state I use. So I got final this one root 2 divided by root 3. Wave function psi 0, 1 divided by 2 plus 1 divided by root 3. Wave function psi 1 comma minus 1 divided by 2. We hope got the A1 and A2 value. Let us check. Psi 1 minus 1 divided by 2. There is 1 minus 1 divided by 2 here. 1 minus 1 divided by 2. Here 2 is equal to 1 divided by root 3. So here I'm going to compare the original equation. What we write in Chell's starting position. 1 divided by 2 is equal to, in A2, wave function psi 1 1 minus 1 divided by 2 plus A3 wave function psi 0 1 divided by 2. So this is the state, right? This is another state, right? So coefficient of A1 and A2 are, so the coefficient of A3 equal to root of 2 divided by 3. A2 is equal to 1 divided by root 3. Okay, let us find A4 and A5 coefficient next. By practicing only you can get these equations. So make sure if you collected these type of things, you need to understand the rules and regulations and the coefficient value. Then you can derive easily. Now I'm going to try to derive A4 and A5 coefficients. So for that, I'm going to take wave function psi 3 divided by 2 comma minus 3 divided by 2. So I want A4 and A5. A4 and A5. Here minus pi equal pi 3 divided by 2 minus 1 divided by 2 is there. Here I am taking 3 divided by 2 minus 3 divided, right? In case if I apply here j plus operator, so we know if you apply j plus operator, it will increase by one step, j plus. So plus 1, then we can get 3 by 2 minus 1 divided by 2. What we want here? 3 divided by 2 minus 1 divided by 2 state, right? Then we can get a4 and a5 values easily. For that only I am taking this state. Okay. So now you can apply. So if you apply j plus, this is j, this is m, right? So m state will decrease. Sorry, m state will increase by 1. Wave function pi 3 divided by 2 plus minus 3 divided by 2 plus 1. After applying operator j plus operator on this state, m state will increase by 1 after applying j comma m plus 1 after applying j plus operator, and you can get eigenvalues. We know j plus operator, eigenvalues j into j plus 1 minus m into m plus 1. So root of j is equal to 3 divided by 2, right? 3 divided by 2 and 3 divided by 2 plus 1 plus m is equal to minus 3 divided by 2 minus 3 divided by 2 plus 1. So this wave function psi is equal to 3 divided by 2 minus 1 divided by 2. So this one is root 3 and pi 3 divided by 2 comma minus 1 divided by 2. So we know equation. So I think this equation. Um, Here I did one in terms of this one is minus. Okay, then only we can get here minus 3 divided by 2. Okay, let's go here. So we know the pi 3 divided by 2 comma minus 3 divided by 2 equal to wave function psi, equation number 2, minus 1 divided by 2, right? This is equation number 2. So in place of this pi 3 divided by 2 minus 1 divided by 2, I'm going to use this psi function. So try to write this thing. So here I got j plus pi 3 divided by 2 comma minus 3 divided by 2, right? So okay, so interchange this equation like this. Pi 3 divided by 2 comma minus 1 divided by 2 equal to 1 divided by root 3 j plus pi 3 divided by 2 comma minus 3 divided by 2. See, I'm going to replace this. by this one. 1 divided by root 3 j plus wave function psi minus 1 minus 1 divided by 2. Okay, this is m1 and this is m2. m1 and m2. 1 divided by root 3. I'm going to split j plus operator into j1 and j1 plus this one and j2 plus here. Okay, 2 plus into wave function psi minus 1 minus 1 divided by 2. So split this operator. 1 divided by root 3 is there common, j1 plus operator. Okay, so it is better to write here as plus j1 plus operator on this state. I'm going to apply plus j2 plus operator. I'm going to apply this state minus 1 divided by 2. Okay, so after applying 1 divided by root 3 root of j1, so this is operator, this is the state, right? Wave function. So I'm going to apply j1 plus on this state. j1 plus, this is m1, this is m2, this is m1, this is m2, right? So if you apply j1 plus on this state, only first, I mean m1 state will increase by 1 after apply. If you apply j2 plus operator on this state, only m2 state will increase by 1. So then eigenvalues are m1, so j1 minus m1 into m1 plus 1, and wave function psi. So this will minus 1 plus 1 becomes to 0, minus 1 divided by 2 plus root of j2 plus 1 minus m2 plus 1 wave function psi. So minus 1 divided by 2 plus 1 minus 1 divided by 2. 1 divided by root 3 into the root of 1 into j1 is equal to 1, j2 is equal to 1 divided by 2. In try to put these values. Okay. Plus 1 minus 1 plus 1 wave function psi 0, 1 divided by 2 plus root of j is equal to 1 divided by 2, j is equal to 1 divided by 2 plus 1, m2 is equal to minus to minus plus, m2 is equal to minus half plus 1. So wave function psi minus 1 divided by 2. at equal to 1 divided by root 3 root of 2. Okay, 0 minus 1 divided by 2 plus this one 1 divided by, I mean 1 wave function psi minus 1 and 1 divided by 2. By simplifying these things, we can get this is root 2, this is root 1, this is okay. So then the root 2 divided by 3 wave function 0 1 divided by 2 plus 1 divided by root 3 wave function psi minus 1 1 divided by. So at this value we can take here j plus 1 divided by 3, right? So I 3 divided by 2 comma minus 1 divided by 2 equal to, we got this one. So try to compare our equation, CG coefficient equation. So this is our CG coefficient equation. A 3, A4 and A5. 3 pi 3 divided by 2 minus 1 by 2 A4 psi 0 minus 1 divided by 2 and A5 minus 1 1 divided by 2. So therefore A4 equal to root 2 divided by 3, A5 equal to 1 divided by root 3. So this is how we get. The remaining thing we can get easily. So A5 up to A5 we got A6 equal to 1. Then we want to A7, A8, A9, A10. 4 coefficient we need. Okay, let's find. For that, I'm going to take since pi 1 divided by 2, 1 divided by 2 is orthogonal to wave function psi 3 divided by 2 comma 1 divided by 2. So we can write these two equations. Okay, this one and this one. 1 divided by 2, 1 divided by 2, 3 divided by 2, 1 divided by 2. So then we can get easily. So we know already A2 and A3 values, right? You try to apply orthogonal condition to these two states. So we can get the coefficients A1 or A2, A7 plus A3, A8 equal to 0, and this orthonormal condition is A7. So if you apply orthogonal condition, you got this one. If you apply orthonormal condition to only this state, what I mean, wave function psi 1 divided by 2 plus 1 divided by 2. So if you apply these two state orthonormal condition, definitely you got this thing. if you apply the same state, wave function psi 3 divided by 2, 1 divided by 2 state is there, right? Same state you can apply ortho normal condition, normalized condition. This is the orthogonal condition. You got this equation definitely. Okay, then from this a to a7 equal to minus a3 a8. So a2 divided by a3 equal to minus a8 divided by a7, because I know a2 a3 values. I'm going to try to put a2 and a3 value here. Root 3 into root 3 divided by 2, right? That equal to minus a8 divided by a7. Therefore a7 equal to minus root of 2 a8, and a7 equal to root 2 1 divided by root 3. So that equal to minus root 2 divided by 3. So how I got here a8 value? So try to apply this a8. So from orthonormal condition value, so if you apply this thing here, 2 a8 square plus a8 square equal to 1, then 3 a8 square equal to 1, a8 equal to 1 divided by root. This way I put here a8 equal to minus, so therefore a7 equal to minus root 2 divided by 3, a8 equal to 1 divided by root 3. Similarly, if you apply the orthonormal and orthogonal condition, similarly, if you apply this, said 1 divided by 2 minus 1 divided by 2 is orthogonal to wave function psi 3 divided by 2 comma minus 1 divided by 2. We can write so orthogonal condition a4 and a9 plus a5 and a10 equal to 0, and a9 square plus a10 square equal to 1. So a4 a9 equal to minus a5 a10, a4 divided by a5 equal to minus a10 divided by a9. So here in case if you try to put a4 and a4 values, then you can get a10 equal to minus root 2 a9. Okay, so a4 and a5 values, we know a4 and a5 values. So a4 and a5 here, a4 is equal to root 2 divided by 3, a5 is equal to 1 divided by root 3. So after putting these things, I can get this equation. So we know orthonormal condition. So from orthonormal condition, a9 square, try to put this a10 square here, 2 a9 square equal to what? Then a9 equal to how much? 1 divided by root 3. So then a10 equal to minus root 2 into 1 divided by root 3, means a10 equal to minus root of 2 divided by 3. So these are the CG coefficient of all CG coefficient. J is equal to 1 and J is equal to 1 divided by. So after that you need definitely write this table. Try to write this table. Very important, this one table. Pi 3 divided by 2 comma 3 divided by 2, pi 3 divided by 2, 1 divided by 2, pi 3 divided by 2 minus 1 divided by 2, pi 3 divided by 2 minus 3 divided by 2, pi 1 divided by 2 comma 1 divided by 2, pi 1 divided by 2 comma minus 1 divided by 2. So I'm using square bracket, square bracket equal to a1 coefficient 1 0 0 0 0 0 and this thing 0 1 divided by root 3 root of 2 divided by 3 0 0 0 and third one 0 0 0 root 2 divided by 3 1 divided by root 3 0 and fourth one 0 0 0 0 0. Yes, we got 1. So here this one 0 minus root 2 divided by 3 1 divided by 3, sorry, 1 divided by root 2 root 3 0 0 0. This one 0 0 0 1 divided by root 3 minus root 2 divided by 3 0. Finally finish this topic. 1 divided by 2. This is wave function psi 1 comma 1 divided by 2. This wave function psi 0 1 divided by 2. This wave function psi 0 comma minus 1 divided by 2. This wave function psi minus 1 1 divided by 2. Wave function psi minus 1 divided by 2. Oh my god. These are the CG coefficients. CG coefficient of CG coefficients. J is equal to 1 and J2 is equal to 1 by 2. Okay, I'm going to stop here. In case if you got any doubt by solving this equation, try to comment below. I'm going to try to clear this. Whatever you got any doubt, I'm going to clear your doubts.